Hello out there. I hope you're excited out there and have some energy to go with the maths. And remember, doing your mathematics doesn't mean observing. Yes, there's some observing, but you need a pen and paper and have your calculator there and try some of the problem. I mean, when you go on break, think about some of the questions. That's a very important part of learning. So we'll explore the measure of central tendency and the dispersion of data. Fantastic. Let's see what we have for you today. So, have you ever thought about this? Very important. How can an investment company calculate risk? Very interesting. How do you calculate risk? What does risk mean? What does it mean to you? Risk, yes, is the worst that can happen to the corporation. Can be something like that. If we look at your money, can you lose it? What is the chance of losing that? So today, or maybe at some later time, we'll actually, if we don't touch on what risk means, is actually the deviation from average, deviation from mean, too much movement. That's high risk. Some of you might have heard of something called volatility, okay, which is actually a risk. So much high deviation from the mean, which we'll actually discuss also today and when we look at the measure of dispersion. Okay. So before we do that, so we'll look at the 5-number summary, the box and whisker. So, but under our measure of central tendency, okay, remember central tendency, you tend towards the center of the data, okay, which are quartiles. Quartiles is 25% of the data, is that the median, the middle one, and the middle of the last 50% of the data. Then the average, which is the mean, also. The measure of dispersion, how the data is scattered, is the range, interquartile range. Okay. And remember that the interquartile range is the upper quartile minus the lower quartile. Okay. Now, some of the keywords: raw data, group data. Raw data, it's like 1, 2, 3, 4, 5, 6, something like that. That is raw data. But grouped data is when data is grouped according to class interval with tally or frequency. And remember, frequency is the total within that interval. Are we all together? Raw data, random numbers, grouped is grouped with class interval, tallies, and frequency. Then we'll look at some keywords: extreme value and skewed. Extreme values are the highest or the lowest value on a set of data. Be together. This can be the minimum or the lowest. Those are the extreme value. Okay. They can affect your average, which is the average, which is the same as the mean. So when we talk about skew, we talk about whether your data is to the left, to the right, or is symmetric. The side of the data is the same as the side of the data. But we'll use the whisker plot to explore that. Okay. Then this is our measure of dispersion, quartiles, average, measure of dispersion range, interquartile range. Let's start with average. All measure of central tendency. 3 average in statistics. We have mean, median, and mode. Those are average: mean, median, and mode. Are we all together? Mean is the average, median is the middle one in the data, mode is the most occurring one. Okay. So those are the averages. Mean is known as average. To find the mean value of set of data, which is the numbers we have, you add all the data value, then divide by how many they are there. Okay. Okay, so this data shows the population in millions of a random sample of 12 countries. So what we have to do is to find the mean population of 12 countries. So what it means, this is 3.6 million, 5.8 million, which is another country. Where do you think South Africa actually falls? Any idea? Are we a population of 3.6, 5.8? I think we somewhere there, around 50-something million. Okay, let's carry on and calculate the mean for 12 country population. So to do that, we have to add all the number divided by 12 because we're working with 12 countries. So how do we do that? We add all the numbers from 3.6 all the way to 5.6 divided by 12. Use a calculator, and if you add all the numbers on top, you get, that's what we get, divided by 12, and our mean is 23.78 million. That's the average of the 12 random country. Okay, now let's look at the range. So the range is the maximum value minus the minimum value, the highest minus the lowest. What is the highest? The highest is 125.6 minus 2.5, which is the lowest country with the smallest population from 12 countries. And if you minus them, we get 123.1 million people, which is the range. So this is the data we had. We had our mean, which we calculated it, happy with that, and our range, which is what we got. Okay, which is the repeat. Okay, our mean. So now, let's look at the estimated mean of grouped data. So what we had raw data, the actual data given to us. We knew this country, the population was 3.6 million. We knew that this country population was 50-something million. But what if data is grouped in a table? How do we calculate the mean? Let's look at how we do that. So we call this an estimated mean. And why do we call this an estimated mean? It's not the actual mean, it's an estimate. Okay? And we'll discuss how we can actually improve the accuracy of this estimated mean. So, an estimate for the mean can be obtained by assuming that each of the raw data value takes the midpoint, the middle of the interval in which it has been placed. So the mean is the sum of all frequency times the midpoint divided by the total number of frequency. This sign, it just means sum. Add, this means sum. Sum is the same as add. This is F, which is F is for frequency, X is the midpoint. Over F, that sign, which is called sigma, it means add. Let's look at an actual example. This is the data, actual data obtained, okay? So it's grouped for us according to age and actually the frequencies. the number of coronavirus, the COVID-19 death in South Africa in 2020 by age. The number of deaths is shown in the grouped frequency tables. What it means, this is the age, okay? And how many people actually died from COVID-19? It's 8. The age, which is 20 to 40, people died from COVID-19. 40 to 60, 715 died from COVID-19. 60 to 80, okay. And 80 to 100, that's the size. And total number of people died from COVID-19 is that 1891. Okay. This is not like the whole year. It's for a certain period. This could have been collected for 2 weeks, 3 weeks, a month, so on. I'm not sure about when. Okay. But it's probably not the whole year or 2 years. It's for an interval, but it was grouped. Now, to find the midpoint, what we're going to do is we're going to say 0 plus 20 divided by 2. We find the midpoint for them. 0 plus 20 divided by 2, we get 10. That's the midpoint. Then we go 20 plus 40 divided by 2. We get 30. That's the midpoint for this interval. And for the next interval, 40 plus 60, which is 100, divided by 2, we get 50. 60 plus 80 divided by 2, you get 140. And 80 plus 100 divided by 2, we get 90. So now we have the interval, the frequency, the highest midpoint, and the midpoint. The frequency just tells us how many people died in each interval. And we can see the highest is 60 to 80. If you have the age between 60 and 80, the likelihood of dying from COVID-19 very high based on that data. Then what are we going to do? We're going to multiply the midpoint times the frequency. So midpoint times frequency, we get 80. We get 3,420, we timesing this times this. That times that, that's what we're getting. And we're just multiplying them. 848 times 140, that's what we get. And we multiply 90 times 206. Okay. Then from there we add everything. We add 80, we add the number, we add that, we add, and we get the total, which is that. Are we together? Now, what do we have to do? We have to divide the total by the total frequency. Okay. So if we do that, the total divided by frequency, we get 93.34 years. That's the average age of dying from COVID-19. But remember, this is an estimated mean, not an actual mean. But I have a question for you. How can we improve the accuracy of this answer? How can we improve the accuracy of this answer? The best way we can improve the accuracy of answer, what I think, if you look at the groups, you have 0 to 20, so we can make the groups smaller. Look at age group 0 to 10 maybe, 10 to 20, 20 to 30, 30 to 40, and so on. Because if you look at the group, it's just so big. 0 to 20, 20 to 40, 40 to 60, such a big interval. So if we can make the intervals and try to estimate the mean, I'm expecting that mean we can improve the accuracy of the estimated mean of dying from COVID-19. Beautiful, guys. So I hope you make sense. We have looked at the mean, we have looked at the range. For the mean, we looked at grouped and raw data mean. So after that, we'll look at more on statistics. So We'll see you after the break. Get some water or something and come back ready. See you soon.